Chapter 12 is on the economics of information. Our learning objectives are to look at strategies to manage risk and uncertainty, including diversification and optimal search strategies. Second, calculate the profit maximizing output and price in an environment with uncertainty. Third, explain why asymmetric information about hidden actions or hidden characteristics can lead to moral hazard and adverse selection, and identify strategies for mitigating these potential problems. And fourth, look at how differing auction rules and information structures impact the incentives in auctions and determine the optimal bidding strategies in a variety of auctions with independent or correlated values. Measuring uncertain outcomes. The variable that measures the outcome of an uncertain event is called a random variable, and probabilities may be attached to these so that we can look at the chance of that value occurring. And information about the uncertain outcomes can be summarized in the mean, or expected value, and variance of that random variable. The mean of the random variable is the sum of the probabilities that differing outcomes will occur multiplied by the resulting payoffs. For example, if we have outcomes x1, x2, x3, etc., and we have q1, q2, etc. as the probability of the outcomes, then the mean is equal to q1, x1 plus q2, x2, etc. through qn, xn, where q is the probabilities, and when you sum them all together, it equals 1 or 100%. The mean does not provide information about the risk associated with those random variables. Notice that in this formula for the expected value of x, that if there is equal probability of all the outcomes, you simply add all the outcomes and divide it by the total number of observations. But here we're allowing for difference in probabilities for each of those outcomes. Measuring uncertain outcomes, variance and standard deviation. The variance of a random variable is the sum of the probabilities that the different outcomes will occur multiplied by the squared deviation from the mean of those resulting payoffs. And here again we have x1, x2 denoting the outcomes, and q1, q2, etc. denoting the probabilities. So therefore, when we look at the expected value, we have a variance as follows. The variance equals the probability times that specific outcome minus the expected value squared. And we do that for each of the various outcomes, and when you sum those together, we get a variance. The standard deviation is the square root of the variance. Risk aversion. This deals with the attitude of risk differing among different consumers. A risk-averse consumer prefers a sure amount of $M to a risky project with the expected value of $M. And a risk-loving consumer prefers a risky project with an expected value of M to a sure amount of $M. And a risk-neutral is indifferent between a risky project with the expected value of M and a sure amount of M. We can look at an example of risk aversion with the area of product quality. Consider a consumer who buys regularly brand X now has a new product available, brand Y. Under what conditions would the consumer try the new product? There would be issues to overcome if you're trying to sell a new product to this consumer. First, what is the relative certainty around brand X? Secondly, at equal prices, we notice that a risk-averse customer will continue to just use brand X. At equal prices, among other things, a risk-averse customer will continue to purchase brand X since that customer prefers a sure thing to a risky project, brand Y. There are two tactics you can do to induce the consumer to try the new product. One is lower the price of brand Y. Secondly, try to convince the consumer that the new product's quality is actually higher than the old product. Other items that we see in practice are chain stores. Chain stores are effective in part because they are standardized, there's a reputation, and there's a chance of survival, so consumers may feel more comfortable buying from a known chain store as opposed to an unknown independent store. Online reviews may also reduce the risk, such as Yelp or any site-specific reviews. And insurance. The fact that you're risk-averse means that you're willing to pay for some insurance to reduce the chance and consequences of that risk. Consumer search enters into the comparison of the price that you're looking at versus the price you're seeking versus the cost you are incurring to continue your search. So when we look for an identical product, we have cost C, and when we look at a particular price quote, you have to decide, is that price good enough, or do you want to continue searching, knowing that There's no certainty of finding a lower price. Here's an example. If there are 3/4 of the stores in a market that charge 100 and 1/4 charge 40, will you search for that one with 40? A consumer observing the price of 40 should stop because there's no price below. What would a risk-neutral consumer do after observing a price of 100 if a search occurs with free recall and replacement? 1/4 of the time, the consumer will save $60, 100 minus 40. But 3/4 of the time, the consumer will save nothing. So the expected benefit of that additional search is 1/4 times 100 minus 40 plus 3/4 of 100 minus 100, or 15. Therefore, the consumer can compare the $15 expected benefit to the cost of seeking out that next store. Here is that description graphically. We have the cost of search, that's the horizontal line. We have the expected benefit of the search. And then we have R, which is a reservation price. Reservation price is the price where you're indifferent between purchasing it and searching for a lower price. In other words, where you would stop. So where we would stop is where the expected benefit of the reserve price is equal to the cost. So here we are content, if you will, with the result of the search. The consumer search rule is that the optimum amount of search rejects prices above the reservation price R and accepts prices below the reservation price. Stated differently, the optimal strategy is to search for a better price when the price charged by the firm is above the reservation price and to stop when you hit or go below the reservation price. To make things a little more complicated, what happens if there's an increase in the cost of search? So we have increased search costs, so the C moves up to C star, and therefore the point at which we would stop searching moves to the right at R star. In this condition, we would accept a higher price because of the level of costs necessary to continue the search.